I'm Anil Kumar, sharing with you a question on indeterminate difference. In these set of videos, you'll find application of L'Hopital's rule for different indeterminate forms. One of them is like 0 over 0, then we have infinity over infinity, and this we're talking about indeterminate differences, which are kind of infinity minus infinity. In other videos, we'll also discuss indeterminate powers. Now, what do we understand by this? The question here is, find the limit as x approaches infinity for x e to the power of 1 over x minus x. Now, in this particular case, what we can do is, we can write this function. Let's first see whether it is indeterminate form or not. So if I write infinity here, then what do I get? X, we have x e to the power of 1 over x, right? So if I write infinity, I get this as infinity e to the power of 1 over infinity. So that is kind of 0, right? So this is 1, so we get infinity. And minus x, and x is infinity, means minus infinity. So we have a form infinity minus infinity, and that's what we mean when we say indeterminate difference. Since we are not very sure what our limit is going to be, will it be plus infinity, minus infinity, or somewhere in between, right? So that is what it is. Okay, so let's begin to solve this. We have limit x approaches infinity. Now the question is, whenever you're applying L'Hopital's rule, you must have noticed that we should have a form which is kind of like this. X approaches a, f of x over g of x, right? So we have to write in quotient form. So first we have to figure out how to write this in quotient form. So we'll do some simplification. Let's take x common, and then we have e to the power of 1 over x minus 1. And now we can write this as a limit x approaches infinity. In the numerator, we'll prefer to keep e to the power of 1 over x minus 1. And in the denominator, we can write this x as 1 over x. Do you see that? So now we have got a form which is conforming to the form which we need, right? It has to be ratio, or it is quotients of two functions, correct? Now, this form, you can apply the rule only if we have 0 over 0 or infinity over infinity, right? So either 0 over 0 or we have infinity over infinity. Then only you can apply this rule. So let's check. If I write infinity here, I get 1 minus 1. I get 1 minus 1, and 1 over infinity is 0. So we have form 0 over 0. So we can apply the L'Hopital's rule. So we normally write with h, or sometimes LH, whatever, and sometimes we just say it. So we'll apply this rule now. Applying rule really means that the limit is same as limit of their derivatives, right? Quotient of their derivatives. So we have d dx of e to the power of 1 over x minus 1 divided by d dx derivative of 1 over x. Now this derivative is, as x approaches infinity, e to the power of 1 over x times derivative of 1 over x, which is minus 1 over x squared, right? Derivative of 1 is 0, okay? And derivative of 1 over x is minus 1 over x squared. Now in this expression, minus 1 over x squared and minus 1x squared cancels off, right? So it could be simplified. This cancels off. So what we get here is this is equal to limit x approaches infinity for e to the power of 1 over x. Now if I substitute infinity here, then what do I get? I get e to the power of 1 over infinity, which is e to the power of 0, and that is equal to 1, right? Therefore, the limit of this function is 1. And that is how you find the limit using L'Hopital's rule. I hope the steps are very clear. I'm Anil Kumar. I have many videos for different kinds of indeterminates where this rule can be applied. So go through them. They are classified in different series. So check those playlists for some interesting questions. You can always share and subscribe my videos. Thank you and all the best.